After researching the crash rates for that Soviet booze cruise called the Tu-22, I found a similarity with this plane and a metric ton of other disappointments so absolutely garbage I can't not make videos about them. Today we're going to talk about this flying list of nicknames, the F-104 Starfighter, with the first on that list being the missile with a man in it, which I think says a lot about how you were going to end up if you flew this thing. You were either going to become a cloud manufactory or rewrite the topography of a runway somewhere. I'm just going to go ahead and tack down that list right now. Among its most common German nickname of Witwenmacher, or Widowmaker, it was also called the Fliegende Sarg, or Flying Coffin, as well as Erdnagel, or Ground Nail. Sorry if I got those wrong, still learning German, gonna need a pass for this one. The Canadians also made a habit of calling it things like lawn dart, the aluminum death tube, and the flying phallus. Hoo boy, almost angered the algorithm gods there for a second.
Don't make me angry. You wouldn't like me when I'm angry.
Anyways, you may have noticed that people didn't like this thing very much, which is kinda understandable when you realize it averaged around a 40% crash rate across the 11 countries it flew for. You might think the Germans aren't being very funny with their nicknames, but I probably wouldn't be making a whole lot of jokes either if the stupid thing cost me 1/3 of my fleet and 1/8 of my pilots. And that's being kinda mid. As in middle of the pack. The US saw a little shy of half their airframes crash and almost 1/5 of their pilots go with them. Considering how many issues this plane had, I'm pretty sure the reason they called it the Starfighter was because the only thing it helped you do was fight the stars for your spot in heaven.
I'm in danger!
You're just obsessing over one statistic. The Starfighter was an icon of innovation and the first fighter jet capable of Mach 2 flight.
Okay, you need to lay off the chips, because I can hear your throat begging for water. And while I will give you credit for that last bit, the Mach 2 gold member status wasn't the only thing the Starfighter was first in. This plane was the first to be trucked around by long-range air transport thanks to a modular design. It was the first to use the M61 Vulcan Gatling gun that all fighters use nowadays, which had to be changed to a linkless feed system because the links kept getting sucked back into the engine like it's a prom night after party. And it was the first plane to use a stick kicker flight correction system to account for high stall angles. And much like that one plane that ruined Boeing's reputation, there were several fatal malfunctions, and pilots usually just turned it off before a flight.
Right. Rico. Manual.
I think the best way I can sum up why all this innovation was a problem is with the following quote: "A good engineer is a person who makes a design that works with as few original ideas as possible." That's by Freeman Dyson, by the way, a theoretical physicist who may or may not have invented the Dyson sphere. You know, that sci-fi power generator that uses a star as a gas tank. The Starfighter may not have run off of a star, but its power output was absolutely astronomical for the time, because it was the first US fighter jet to use the J-79 engine. This engine was made famous for its later use in the F-4 Phantom II, but it was first used in the F-104 Starfighter, and just like every time something gets used for the first time, it had some problems. For one, the compressor stator blade suffered the distinct irony of not responding well to sharp changes in temperature.
Fire bad.
So if you don't know, a jet engine has two main moving sections, the compressor and the turbine. They both kind of work the same way, but they're opposite to each other. The compressor adds thrust to the engine by compressing the air and slows it down so it can be lit on fire in the combustion chamber, while the turbine takes power out of the flow to keep the engine running. Both are made up of sets of little wing-shaped blades, some that spin and some that don't. The blades that spin are called rotors, and the ones that don't are called stators, and a set of rotors plus a set of stators is called a stage. Got it? Cool, moving on. The J-79 stators were variable incidence, which means they could change the angle that they sat at in the airstream, kind of like a valve. The problem with this extra mechanization was that they would sometimes close and choke the engine due to those sharp temperature changes I mentioned earlier. However, these changes could be caused by something as simple as trying to take off after being parked for too long in the sun. I'm trying to tell you that the Starfighter ran on an engine that would effectively suffocate from a friggin' sunburn. To make things worse, the J-79 also had an adjustable engine nozzle that would sometimes fail and auto-contract on takeoff, which would tank the engine's thrust output and force the pilot to either abort the takeoff or drive headfirst into their local ecosystem. And even if aerodynamics were simple enough to allow you to compensate for that with your afterburner, sometimes that piece of hot garbage would blow itself out like some kind of sentient birthday candle, and that's assuming it even lit in the first place. Those technical difficulties are actually even worse considering the, well, relative simplicity of the original afterburner system. See, the J-79's afterburner originally wasn't modulated, which means you couldn't scale it to meet your need for speed. The engine started with only two settings that would allow a pilot to either break the sound barrier or Double it. Zero gray area. The engineers said we're either going to give sound an existential crisis or we're not building this plane. And that sounds great, but there's a slight problem with that, because you either use some of your fuel or frickin' all of it.
I'm still gonna send it.
And that was a problem because the hyperspeed hypodermic over here didn't have a lot of gas to begin with. All of the Starfighter's fuel was stored in the fuselage because its wings were too thin. This jet had a leading edge, or front of the wing, that was just over 1/8 of an inch thick, which is about as thick as 2/4. That may not seem like a lot, but this meant it was sharp enough that it could injure maintenance crews who tripped and fell onto it, which meant they had to give the wings a pair of special shin guards every time they needed to fix something. This razor-thin tapered wing and its small wing area was recognized as the most efficient wing structure for the supersonic flight requirements the Starfighter was meant to fulfill. But this resulted in a stupidly high wing loading. Since most people probably aren't going to catch that, I'll elaborate. An aircraft's wing loading is actually a very simple thing. It's the ratio of the aircraft's weight to the area of both wings combined. It's literally just the amount of weight any portion of the wing carries. The problems with having a high wing loading, though, are numerous. Since each portion of the wing needs to generate more lift to equalize the weight it's supporting, that means you need to be traveling faster in order to actually fly. First off, this is a huge issue for turn rate. I covered this in a previous video, but in order to make a sustainable turn, the wings have to resist the air in a careful balance with the thrust. For the Starfighter, this meant that rather than turn, it would, in the words of one US pilot, bank with the intent to turn, or as I prefer to say, it turns like a sack of wet bricks. Sir, we have places to be, do you mind? The other big issue with high wing loadings is the high takeoff and landing speeds. The Starfighter's landing speed was so high that a special system was required just to force the laws of physics into allowing it to fly. This system took air from the engine and blew it over the landing flaps to lower the speed the plane could land at, which is a great idea, except the engine had to be run at more than 82% power during the process, which is really high for landing and kind of defeats the purpose of trying to land slower. The high landing speeds probably would have been easier for the pilots to think about if it weren't for the additional stress of also having downwards facing ejection seats. We've finally come full circle to the plane that got me started on this mess in the first place. And much like the flying party barge, the downwards facing seats were intended to prevent pilots from worrying about clearing the tail, because apparently the ground is somehow less of a problem. And the tail itself was a hazard due to the risk of flutter at high speed, which is just a fancy way of saying if the Starfighter went really fast for too long, like it was supposed to, the tail would just shred itself to Narnia. Thanks to all of these issues and so many more, this plane was pretty much universally hated and got dogged on by the highest scoring ace in history. Erich Hartmann, a German fighter pilot from World War II with 352 kills officially credited to him, referred to the F-104 as unfit for combat. The god of dogfighting himself straight up took one look at this thing and said absolutely not. And yet somehow, Germany was among 15 countries to add this Mach speed monstrosity to their ranks. Unfortunately, the reason for this was much less than savory. At this point in time, Lockheed was going broke, and they decided to do what any desperate big company does. They decided to do it wrong. In 1975, numerous executives at Lockheed were convicted of using government connections and bribes to force the Starfighter and other Lockheed aircraft to be sold into foreign service. While Kelly Johnson, the founder of Skunk Works, was not involved in the scandal, he was so disgusted when he learned about it that he nearly resigned from Lockheed altogether.
Quit. Don't quit. Noodles. Don't noodles.
I need to stress to you how major this is. Kelly Johnson invented Skunk Works all the way back in 1944 to create the P-80 Shooting Star, America's first operational jet fighter. He led the design of multiple critical aircraft that came out of Lockheed, including the SR-71 Blackbird, the fastest plane in history. This guy is Lockheed's engineering equivalent of a main character, and he was about to jump ship. The F-104 was such a critical mass screw-up, there was a greater than 0% chance we almost never got the fastest plane in history, and that title almost went to a Russian plane, the MiG-25. Thankfully, that never happened, though. The SR-71 still got to be a world-class treasure and one of America's many claims to military fame. But the F-104 definitely did not get the same treatment. Its capability limits and the bad taste it left in the entire world's mouth expedited its retirement out of necessity, burning away what could have been a decent reputation like a bad re-entry. Thank you for watching. If you like what you saw, please consider checking out my other videos or my live streams over on Twitch. You might like what you find, and links are in the description. Until next time, dismissed.